welcome everyone. For those that have just joined, please make sure your camera is switched off and your mic is muted throughout the presentation. Today we're going to be presenting on de-risking your hydrogen pipeline development program with human AI synergy. I'll just move on to the introduction. So I'm Lauren. I am the head of the pipeline project at Continuum Industries. Continuum Industries are a software company, and the idea for the technology was first conceptualized at the University of Edinburgh by a small group of engineering students. So this is a really exciting day for us to be reflecting on our work alongside SGN on a project of this scale, which is H2 Caledonia. I'll just hand over to you, Ali.
Yeah, Ali Scott. So I'm a project manager in the Hydrogen Solutions team as part of the Future of Energy department at SGN. So for those who aren't aware, SGN is one of the 4 gas distribution networks in GB. So we own and operate the gas distribution networks in Scotland and the southeast of England, supplying around 5.9 million customers. So this project sort of is, I'll come on to it, but effectively our strategy is underpinned by the conversion of the gas networks to hydrogen and the creation of a hydrogen economy. And we need a lot of new infrastructure to do so, which I'll explain in a moment. But thanks all for joining.
Thank you. So again, for those of you who've just joined, please make sure you are muted and your camera is off for the presentation. If you have any questions, please pop them in the chat, and at the end we'll have time to go over them. If in the case that we don't have time to go over your question, we'll be in touch with you after the presentation to follow up. So today, Ali is going to discuss the challenges of unlocking the hydrogen economy, and then we're going to compare the traditional approach of optioneering to the new approach of optioneering, utilising Optioneer, which is the product Continuum Industries develop. We're then going to look at how this was employed in the context of H2 Caledonia. We're then going to summarise the challenges and opportunities of this project, and then we'll reflect on the key results and key learnings before we have time for a Q&A and close up. So just to introduce Optioneer, Optioneer is a GIS-based transmission infrastructure planning platform. It's specifically designed to identify and assess route options for linear infrastructure. It's mainly used by asset owners and developers, so it's a tool specifically designed for the use of experts in the field, as we are looking to overcome the challenges associated with achieving net zero. Of course, today we're going to be looking at it in the context of the hydrogen sector, but we do work across the water sector, on and offshore cables, and the electricity sector too. To date, we've been used to evaluate over 40,000 kilometres of assets across 65 different projects. We're being deployed in 17 different countries and have over 150 users on the platform. And I'll just hand over to Ali to discuss the challenges of unlocking the hydrogen economy.
Thanks, Lauren. So this graph you can see here, I'll explain what it means, but it's effectively the exam question we have. So this demand profile is the design profile for the gas system in Scotland. So the thick blue area, which corresponds to the primary axis, is daily demand, which we project, and the system is effectively designed to deliver. The lines, the other lines, which correspond to the secondary axis, show the different levels of demand that you see on the system. So the one at the top is our peak demand, and it's effectively the system design into the distribution systems. So it's as you can see, it's very, very high, and it corresponds to basically the worst winter's day in 20 years, and that's how the system's designed. So it's always inherently oversized. The other lines are kind of average demand. So the purple line is effectively annual quantity divided by the hours in a year, and the orange line is daily quantity divided by hours in the day, to show that variation. But the sort of key things we want to sort of point out here is the intra-seasonal mismatch. So obviously we use a lot more gas in the winter than we do in the summer. So designing a system to meet that demand profile is really quite challenging. And it's why we've used gas to do so for so long, because it's storable, transportable, and quite dispatchable as well. So what we're trying to design is the infrastructure that's needed to supply this with hydrogen, which poses a few challenges. So if you were to design, you have to have availability of that blue line at the top there, but if you were to design production to that number, then you'd have a lot of redundant production most of the time. And likewise, if you were to do it to the average, then you need to have a plan to meet those peaks. So you do need a lot of storage, you need infrastructure. So effectively what we're trying to achieve is this demand profile. How do we supply it in an affordable, safe, practical, and in a net zero way? And we're looking at how we do that with hydrogen, and we need a lot of infrastructure to do that. So we'll move on to the next slide. It's quite similar, this slide. Yeah, so this is Scottish energy demand over the past 10 years or so. So you can sort of see it's to sort of highlight the difference here between the transport sector, electricity sector, and the gas sector. So again, you can see that quite severe profile change, which tracks obviously the seasons, but it kind of shows the peakiness, if you will, of gas, and the infrastructure is designed to facilitate that. So and obviously there's an interesting drop in 2020 with COVID, which is always I'm always shocked by how suddenly and quickly that falls away. But it's just to highlight that from Scotland as well. If we go to the next slide. So this is a schematic which sort of explains how the gas networks operate. So the NTS, by National Gas Transmission, carries the gas from its production sources, from the terminals, and then it's sort of passed down pressure tiers. So it's passed into our local transmission system, high pressure system, which itself is connected to large loads such as industry, power generation. It's then passed down further through pressure reduction stations into individual gas grids, which are in this diagram, the hexagons, which are then passed down through intermediate pressure, medium pressure, low pressure to people's homes. And the point of this one is all the gas there comes from, it's a top-down approach. So it comes from the NTS and passes down to customers. And if you're looking at this and think, how do you transition this safely away from gas to hydrogen? You can't, unless you have a back feed somewhere. You do need new infrastructure to establish that connection. So that's why we need, we're designing this sort of high transmission scenario of a new hydrogen trunk line, which was in the next slide. So adding this in, which if you route it, connecting to where hydrogen production is emerging hydrogen storage, industrial users, and at the national offtakes to allow blending potentially. If you want to blend at the highest pressure tier, you can. Also linking to wider GB, it starts to create the sort of transmission that we need of hydrogen, which is kind of independent of what heat policy ends up being. But if you route this in such a way, you can, the next slide, Lauren, you can design systems to connect into those gas grids. And each gas grid is different in terms of its practicality and what you need to do to it to convert it to hydrogen. And we're investigating that through these projects. There's quite a wide variety of practical challenges and costs. Like some grids you don't need to do very much to, some you need to do probably an impractical amount to. But what this effectively does is it links together hydrogen production and any credible use of hydrogen across the economy, because we know that hydrogen can be used in any sector, but it's kind of that, there's always debate around where it will be used. And this sort of creates the infrastructure which allows that to unfold and people to make that choice. Another slide. So just a bit of background on the project. So this is our feasibility, effectively, of the system transformation infrastructure we think we need to allow Scotland to a hydrogen economy to develop in Scotland, and also to provide the strategic infrastructure to convert the gas networks away from gas to hydrogen, or indeed just stop or move them off gas altogether. This was carried out by Wood a couple of years ago, and it was an options appraisal, effectively looking at what's the high level infrastructure plans that you'd need and what's the optimal way to do this. So this looked at a variety of different strategies, so like offshore transmission pipelines, repurposing onshore, primarily green hydrogen, primarily blue hydrogen. And the solution it landed on at the time, and it may give a different result now, given how much things have changed in the past sort of 2 or 3 years, a sort of distributed blue hydrogen backbone connected through a new transmission line, with green hydrogen then emerging as we go through the decades to move that away, and especially as hydrogen storage develops. So this was sort of the backbone of of the sort of structure of what we were planning. We've just about finished phase 1 of this, which was our Aberdeen Vision pipeline, which is connecting St Fergus gas terminal to Aberdeenshire and the city of Aberdeen. And sort of follow-up phases, we're targeting the Central Belt and then Fife and the East Coast. Alongside this, our in-house teams are analysing each gas grid to understand what you actually need to do to them to make them ready for a conversion to hydrogen, in terms of sectorisation, reinforcement, parallel mains, to sort of make this, because the whole point of this is to make it constructible. Move to the next slide. As I mentioned, one back, sorry. Aberdeen Vision, which is nearly finished, is sort of phase 1 of this programme. And what this has done is it used Optioneer as well to route and design, or to route the options for a new transmission pipeline linking St Fergus down to the city of Aberdeen, the strategic locations along the way. And this pipeline sort of been designed to a pre-feed level where we now have a corridor, and that report is, I believe, in its sort of final stages. Alongside that, we a sort of sectorisation analysis was carried out of the city to basically break it up into chunks and work out the most logical order to basically switch people off gas and switch them back onto hydrogen in a way that manages safely down the gas demand and manages up hydrogen demand. So this facilitates blue hydrogen production at St Fergus, and also gives opportunity, because it's coastal, for green hydrogen production as it emerges over time. The corridor for this, we used Optioneer to develop the options, and it was about 1 week we had the first sort of option look within a few iterations, which Lauren will come on to. And then, so that was phase 1, and then phase 2 is on the next slide, is H2 Caledonia. So it's a slightly different image, this. And effectively, the scope of this project is a pipeline between where the Aberdeen Vision pipeline ends, just south of Aberdeen, and the border with England, where the NTS crosses the border, with multiple points along the way linking together hydrogen production, storage, and strategic locations on the gas networks. This is the image we announced the project with. We're working quite closely with National Gas Transmission on this project, because obviously Project Union is looking to repurpose, and this project can kind of be seen as a high new build transmission scenario. And what we plan to do with this is take this corridor and sort of overlay it with all the transmission infrastructure, the NTS and the LTS, our own system, and try and look at actually which bits we need to build, because we don't want to overbuild it, if we can avoid it. So there may be sections, as I mentioned, if you can find a sort of loop, and it's all about ensuring there's enough capacity for everything and you get enough energy moving south, because the Scottish Government have got really quite bold ambitions for hydrogen transmission in general, just moving south, whatever happens with where it's actually used. So you need a lot of pipeline infrastructure to deliver that energy, which really unlocks particularly the offshore wind sector in Scotland. So we'll move to... So yeah, so this is kind of how, sort of a very high level look at how we would traditionally approach pipeline routing and how any sort of business would. So the ideal route for a pipeline is obviously an unconstrained route from A to B in a straight line with nothing in the way, which is never realistic unless you're perhaps in a desert. And in almost every case, and particularly in Scotland, you've got a whole range of constraints, and you need to very carefully rationalise and navigate around those environmental, urban constraints, topography, and then all the existing and planned infrastructure in the way. So the way you would do this is you sort of collect and rationalise that data, typically in GIS, and then it's quite a sort of primarily a human-led process of developing those corridor options, considering those constraints, to provide you with a few corridor options, which you then you can then micro route through basically validating those sites. So you need to visit the key crossings to check that what you've proposed in terms of method of crossing and method of lay is valid, and then you can micro route around challenging aspects and basically check the challenging parts. The ideal world at feed level, you would walk the line completely to check it in totality, but you'll see the scale of these projects, it's a little bit impractical for us at this stage. You then sort of select and justify your route corridor, which is really important, because you need to prove, because there's never a good route for these things. It's always, I always describe it as like the least bad route. So you need to prove why you've chosen that route and say why we've gone this way and not another way, and sort of quantify it in a way to get to, as part of your consenting strategy. And that's kind of where the pre-feed remit ends for us. And the next stage for us is sort of a feed detailed design of that construction approach, followed by an FID procurement of the in the supply chain, then construction and commissioning of the pipeline and anything connected to it. So pass now on to Lauren to talk about how we've approached this in a slightly different way for this project.
Of course, I'll talk on mute. Perfect, thank you, Ali. So this slide is about comparing that conventional approach to optioneering with the approach that we applied for H2 Caledonia. So as you can see by this diagram, the platform optioneer shines the most in the early stages of the project, so it is an early stage development tool. The first two stages are quite similar, but with some key differences. So in the first step, we set up the project area in Optioneer. I'll take you into the demo project area soon just to show you what that looks and feels like. We then populate this with the GIS data and define the routing assumptions. Again, this is a very standard step, but there's two key differences here. When we are gathering that GIS data, that's put into a platform that everyone in the project has access to. So they can go in, they can review the data, interact with it, leave comments, highlighting high risk constraints. And then when we define the routing assumptions, we bake that into the software. What this means is when we are working on projects in the future, we can quite literally copy and paste that defined routing assumptions into the next project, and then these can be iterated on to account for the particular challenges of future projects. The next stage of the development is the AI part. And this is when the optioneer will scan the project area and highlight key opportunities in the project area with regards to your corridor. So it'll be looking to optimize for cost, of course, safety, and mitigate risk with regards to consent and buildability. At this point, we then refine and iterate. So we have the team come into the platform and then they improve on these results based on their experience and their local knowledge. So we add the benefits of a more qualitative understanding of the project area. The outputs from Optioneer then feed into all of the following sections of the project and help de-risk them and reduce their timeline. So when you're going for your site visits, you'll be aware of where your crossings are, the type of crossings, and potentially which trenchless technique is required, if one is required. And you'll also, what we're typically finding from our customers is that this site visits, when you've been developing the corridors in Optioneer, require less rework afterwards. Then moving on to the selection of your preferred corridor and development of your consenting strategy. The output metrics from Optioneer can be used to develop a screening criteria that can also then be have your consenting strategy derived from this using data-driven justifications, which are more robust and less subjective. Then moving into the feed and detailed design. So Optioneer will consider a lot of the things that are considered high risk in terms of designing your pipeline. So it will mitigate these. And essentially what we're aiming to achieve is getting to that, the bottom line, the commissioning, sooner and with less rework. So at this stage, I'm going to do something a little bit inelegant and just jump into Optioneer. So excuse me whilst I just reshuffle my screen. Okay. So I'm a way to show you just a demo space that we've got in Optioneer. As you can see, this is a region in Scotland, and we have it populated with some GIS data, which is modelling some of the main constraints. So here we have some buildings which have safety buffers around them, and then we're also looking at some of the key environmental concerns as well. You'll also notice that there's quite a lot of comments in the project area. So this is where our team members have gone in and they've started to highlight things that they consider to be high risk. So what this means in a live project is that when people are welcomed onto the team, they'll be able to go in and clearly see what areas are being considered as high risk and maybe need more attention or consideration in the project. And then I'm just going to change slide here. So then at this point, once we've input our routing assumptions and modeled our construction assumptions, we then allow Optioneer to scan the project area and highlight the key corridors. So this is one of the outputs from the AI engine. This is something we call heat maps, and these essentially highlight promising corridors. You can also see this can be used in conjunction with the 3D tool to begin to visualize where we potentially consider high risk in terms of topographical factors and maybe locations you would like to go and consider for your site visits. From these corridors, we select the most promising ones that we'd like to take forward, and then we supplement this with the metrics that are provided by Optioneer. So this will allow us to understand the key trade-offs. So, if you go to the west of a town over east of a town, what does that mean in terms of route length or capex or impact on environment? And we can build these narratives from the metrics that are provided. So here's a subset of the metrics that Optioneer can provide. So of course, the total length of the route, the number of residential and commercial buildings around the route. So this helps us understand the potential impact on communities or local economy. Of course, we have metrics which are associated to or reflect the impact on environmental constraints. We have a summary of the types of crossings and the number. And then, of course, beginning to understand which type of techniques we're going to have to utilize to overcome major crossings and constraints. So that was a very quick sort of overview of the platform. I'm just going to share the slides again. We do have more information on this, of course, online. And please do get in touch if you'd like a more in-depth presentation. Okay, can you see my screen again? That's just jumped to the beginning, so I'm just going to shift through them. Okay. I believe you can see my screen again. Is that correct, Ali? Perfect.
Yeah.
Great. Okay. So Ali's already provided a pretty good overview of the H2 Caledonia project. But just to summarize what this means in terms of Optioneer, we are essentially connecting 52 nodes. This is comprising of, potential hydrogen production locations, industrial off-takers, national off-takes, and also strategic locations. And this will be tying into a gas network that supplies 723,000 customers. This here on the right is a screenshot of the project area in Optioneer. And as you can see, it covers most of Scotland. And there's some constraints here we've got visible just to highlight what the key concerns were going into the project. And this includes, of course, the major river crossings, so the Tay and the Forth. We've got regional parks in the area as well, so Lomond Hills and Pentlands. Major topographical concerns, and including the Cairngorms and the Lammermuir Hills. Of course, in Scotland, we have vast ranges of peatlands. And then, of course, we're also having to navigate the built environment, including the cities of Perth, Edinburgh, planned and approved wind farms, and of course the NTS. So we spoke a little bit about defining our routing assumptions, and I just wanted to go into a bit more detail of what that actually means in Optioneer. So there's 4 key points I want to cover here. So the first is constraint classification. This is essentially when we tell Optioneer what is desirable and what is undesirable to route through. And we have this scale on the right-hand side, which summarizes how we choose to do this. So it's a 6-class scale, going from class 0, which is considered a constraint that has no risk or no impact on the development, and a class 5, which is a no-go, and then it varies in severity as we go up. So what we typically do is we take our GIS data layers, which will reflect certain constraints such as buildings, woodland, triple SIs, and then we will assign a class to them. And this will allow Optioneer to determine which constraints are most unsuitable or suitable to be traversing. The second aspect of this is the building proximity distances. So we will be modelling safety buffers to ensure that we are maintaining a safe distance from buildings and highly populated areas. We'll also be defining construction assumptions, so looking at which construction techniques will be required to overcome certain constraints. And then we're defining some cost models as well. So defining different cost models for different sizes of pipelines so that we can also compare different scenarios and in more detail. Then we moved on to the second stage, which was generating the route options in the project area. So this screenshot to the right here is a kind of overview of some of the constraints that and some of the routes that were provided by Optioneer. And then I just want to work through the kind of three main iterations that we went through on this project. So iteration 1 was undertaken in about week 4. So we took about 2 weeks to set up the project area, define the routing assumptions, and run Optioneer to develop some corridors. And this iteration was all about understanding what to actually connect via the trunk line. So we've got a lot of nodes, and not everything is going to be sensible to actually connect directly to a trunk line. So this was about understanding what is feasible. So we ran Optioneer, and we understood visually what a pipeline, a trunk line would look like, based on the routing assumptions we defined. We then supplemented this with some of the metrics to understand, what would be the length or the cost and the environmental impact of developing this trunk line. And from that, we were able to define the locations that we'd actually be directly tying into the trunk line and those that would fall into the spur network. Iteration 2. So we were on iteration 2 by about week 6. At this rate, at this stage, we are focusing on optimizing the routes in Optioneer. So that was, looking for more direct routes that are closer to the coast and therefore closer to customer bases. And we're also looking at focusing on getting diverse corridors that will allow us to overcome the major constraints in the project area, including the Pentlands, Lammermuir Hills, of course, the Forth and the Tay, and the major wind farm developments. So this image here just is a slightly zoomed in version of the Forth of the Firth in Optioneer. And as you can see here, we've got, of course, crossing at different locations will require quite vastly different lengths of trenchless techniques. And we also have other infrastructure crossings that were potential opportunities. And of course, trying to mitigate our impact on the coastal communities and also the environmental designations in this area. The third iteration was undertaken in week 8. So this is when we were looking to select the actual preferred trunk line option in order to develop the spur network off of this. So this is when we utilised screening criteria and the outputs of Optioneer to understand what our preferred option would be, and of course understand the trade-offs, and then look to develop the spur network to connect the remaining nodes. So I've spoken a little bit about the development of a screening assessment throughout this presentation. So I just wanted to go over the main benefits of why we would utilise the outputs from Optioneer to do so. Essentially, the data-driven approach allows for a more robust consenting narrative to be developed. Everything that you're stating can be backed up with numbers. The justifications are traceable and less subjective. So if you are questioned during the consenting process or through public consultation or stakeholder engagements, then you have some numbers to justify your decision. The methodology is repeatable. So this means that we can apply this in future projects. There's no need to reinvent the wheel every time we're starting a project. The results can be quickly updated. So if iterations are required, then we can rerun this in Optioneer very quickly and get the updated metrics out so that we can update reports and presentations and also understand the trade-offs that we were making with that iteration. And this is, I think, the key one, is it allows the team to focus on the greatest challenges. So by having a data-driven approach, which will allow you to justify the key things in the that you have to overcome during the consenting process, you will allow this will free up the team's time to be focusing on the key challenges that we cannot standardize. So the key metrics we were using in the screening criteria were, of course, route length, capex estimate, including material and installation costs, looking at the number of crossings and the type of crossings between from motorways and rivers, etc. We're looking at environmental impact, the number of buildings around a route, again, to understand, the impact on communities, of course, public safety, and the impact on local economy, and then also looking at topographical factors, so making sure that we're mitigating any risk to buildability due to topographical factors. And I'll just hand back to Ali to discuss the validation and site visit stage a little bit more.
Thanks, Lauren. So once we had the project ran where we had a sort of preferred corridor route, it was a corridor, so we aimed for about 1 kilometre most of the time where it was possible, but obviously pulling that in where it wasn't possible. So Optioneer sort of gave us a few options for like major crossings, and the whole point of this project is to de-risk it as far as possible, within the sort of tools we had and the constraints of the project. So it has to be constructible, really, as a route corridor. So it was a few weeks ago now, but we spent a week traveling around, visiting these sort of key vantage point surveys. So just said Wood are the principal contractor for this. So we're around with the Wood team, looking at the sort of various options across areas such as the Tay and the Forth, and it allowed us to carry out micro routing at that point. Also, we had a sort of suggested method of lay for different crossings, sort of from sort of HDD, micro bore, auger bore, things like that. So it was kind of just getting a sense of whether that's practical, and then making appropriate changes to the route if we thought we needed to. So, as I say, you can never be sure you can build this, but we're trying to de-risk it as far as we can. So in addition to those vantage point surveys, we're looking at the moment as a potential for a LiDAR survey of the topography, because we don't want to, you can only be sure if you walked the whole thing, and you can say it's a very long walk. So we're trying to get a sense of how we can analyze that topography to check on, because it's one of the biggest challenges actually. Doing this in this approach sometimes doesn't give you a full appreciation of the slopes that you're trying to put pipelines in. You can put a pipeline anywhere, but it's just more expensive and more difficult. So it's trying to create that path of least resistance, and we're nearly complete now in terms of that phase 1 corridor, and sort of starting to develop the strategy to develop it. But the whole point of this is that that process we undertook with Continuum allowed us to get to that point a lot quicker than we otherwise would have in terms of that early stage of pipeline development. So I think that next slide. It's back to you, Lauren. Oh, still me. So in terms of the challenges of this, and this is a little bit more holistic in terms of how you construct these in terms of when you're considering it. So we've sort of talked already about these major crossings. Some of them really are quite significant. So, the crossing of the Firth to Forth, for example, it's not really been done probably since the NTS was laid. You need to consider things like, how do you access the route? So, as you can imagine, a lot of the route option is cross country. You have to think, how do you get the equipment in? How do you get the people in to construct that in terms of that design? Are the roads wide enough? Are the bridges strong enough to get those equipments in? The key thing here as well is justifying why we've selected where we have, and understanding the sort of trade-offs we've made along the way. So if no one's ever going to be happy with this fully, so it's kind of trying to sort of justify why we've gone the way we have, because if you change something further up, it will have impacts all the way down potentially. So another key challenge of this, and something we're grappling with right now, is the whole sort of concept of this pipeline is to link hydrogen production with where demands may emerge, and it's understanding kind of the merit order of those demands and where we think hydrogen will be used first. So it's sort of phasing the construction with where we think that will emerge, and also with the construction timelines of the various production sites and potential customers that are sort of being facilitated by this pipeline. So we're sort of creating that route to market, but it also requires a sort of really quite close alignment with producers and customers as well. We sort of mentioned as well the sort of public safety, and I see there's a question pops up in the chat around the regulations we've used for this. So that's kind of been built as well into the software. So the sort of buffer distances we look at, and where we do need to go closer to an area, if there's like a pinch point, for example, then there are ways to you sort of thicken the wall, for example. And then the last sort of challenge with this as well is the supply chain. So this is obviously an enormous project. It's about 600 kilometres in Scotland and 600 kilometres in the south. We're doing a very similar one in our southern LDZ. So obviously it's a lot of steel, it's a lot of people, it's a lot of machinery. So it's understanding, we're trying to basically establish what is our shopping list. What do we need? How many people do we need? And trying to understand what the supply chain is capable of delivering right now. And if it isn't, which we suspect is not, as I say, there's been certainly not all within the UK. It's understanding how do we get up to that level. So one key element we're looking at is the sort of base case is our sort of X52 low strength steel, which is typically what the LTS is constructed of, which has kind of been accepted. So in general, without being fully proven yet, suitable for hydrogen in terms of repurposing, and certainly for new build. But there is some evidence now starting to emerge that a higher grade of steel might be also useful for a new build pipeline, which would be really handy because it would completely reduce the steel requirement significantly and really make it a little more constructible as well. So we're looking at those from that base case, we're looking to optimize as far as we can to demonstrate it. And this is like one of that, the Optioneer software has allowed us to do that in terms of the route, but we're trying to go further with that and look at the materials side as well. Pass back to Lauren.
Thank you. Oh, excuse me. So just taking a look at some of the opportunities that we had in the project. So the environmental impact of the development could be understood more effectively and at an increased granularity for this stage of the project. And of course, because we can measure that, we can then optimize for it and try to reduce it as much as possible. Of course, throughout the whole project, we have logged the decisions in the software. So these are all traceable, and these will be supporting SGN going forward, including obviously being supplemented by the metrics. Transparency within the team is a big one. So SGN would, and of course Continuum Industries, we were all working in one platform together. So we can all see each other's work, we can all see each other's progress or their concerns, and we can work around that. Multidisciplinary working is also quite important. So a lot of the meetings that we had were designed to include everyone from the team so that everyone's concerns could be captured, so that when their kind of part in the project comes around, that their role is made easier and we're not kind of hitting any unnecessary risks. And of course, quick iterations when required. So when Ali was going out to the site visit, we can feed that information back into Optioneer, rerun the routes and get the metrics out very quickly. Similarly with survey data, so if people are going out to take surveys and something is found, then we can accommodate that in the platform very quickly, and rerun the routes, get the metrics out, update our presentations and reports. Just to summarize the key results from the project. So the entire project, we routed the entire network within 3 months. This was also inclusive of H2 Connect, which was the similar project across the south coast. So a total of 600 kilometres of the hydrogen pipeline was routed. This was actually specific to Caledonia. It was a very similar for H2 Connect, so about 1,200 kilometres, if you want to count both projects. The H2 Caledonia, we tied in 50 strategic locations, and we also established a baseline methodology for future projects. So essentially increasing the efficiency that we're going to be experiencing going forward. I just wanted to share a quick quote from Kirsten Gardner, who was also on the SGN team. I'll let you read through this in your own time, but I just wanted to pick out a subsection of this, which is the middle one. So the software allows clients a high level of autonomy, enabling us to assess developing route options in our own time. This is essential for complex impacts or issues that are best dealt with offline rather than in large group review sessions. And I think this quote for me particularly is very interesting, because I think it highlights that the tool and having everyone in the team having access to all of the considerations, the data, and also everyone else's opinion is quite empowering for people in the team to actually go in and have their input and suggest new options or improvements. So yeah, I really enjoyed that quote. And I'll just hand back to SGN to discuss their key learnings.
So for us, the key point of this is to create something that's constructible, credible, buildable, and justified, to inform our feed as well, because it's quite a major feed project, as you can imagine, for a project of this scale. So reducing that risk of future changes, everyone knows the further you go in a project life cycle, the more expensive and more impractical it is to make changes to it, especially if you start going to the consenting process. So this sort of human AI approach we took, using the software, has allowed that acceleration, the appraisal of these options corridors, and that sort of full audit trail, if you will, of how and why we've chosen the option we have, which is really important in terms of the there's a question popped up in the chat, I think, about when we plan to engage with sort of consenting process. So part of the project is developing that strategy. So for Scotland, we're sort of trying to iron out exactly how we. It's a little bit of a first of a kind element to this, to be honest. So we're sort of trying to iron that out. But I think the key point of this is we're trying to create a really powerful justification and a robust process as to why we've done this, which also allows us to quantify the environmental risk and impact as well, and it's sort of evidence that it's the lowest it could reasonably be, sort of balancing that with the cost of the project as well. So that's this has been invaluable because there's no way we could have done this project in the time frame we have. It only kicked off in February, so we do have a sort of full phase one route now that we're iterating, and we expect the project to wrap up sort of February, March time this year. So it's been, yeah, it's really powerful, and I think it's been nice to. It's been a really sort of positive process for us and experience working with Continuum as well. So, I think that's.
Thank you. Okay, so I'll just head to the final slide, which is just if anyone does have any questions, now is a good time to get popping them in the chat, and we'll just have a look through. There seems to be quite a few in already. I'll just go to the top. So what type of assumptions were used in terms of legal regulations and standards when creating parallel for H2 and NG corridors, safety hazard and fire zones distances? So we touched on this a little bit. I believe the bulk of the regulations around this come from the TD1 documents. So these were analysed, and then we modelled the GIS data to accommodate these. And then where we couldn't kind of catch the nuances, i.e. so these are based on the pressure of a pipeline. So when you are developing obviously a network which is going to be running at various pressures, we took a worst case scenario approach where we couldn't necessarily determine the exact distances. The next question, sorry, was there anything you'd like to add to that, Ali?
No, nothing to add to that. It's primarily TD1. I think it was edition 6, supplement 2. It's the most recent version, but it's, yeah, that was kind of informed the proximity distances and whatnot for the pipeline.
So then we have who decides what band of interest is looked at for starting the process, i.e. 30 kilometres wide, etc.
So that we don't quite know yet. So it's coming. I think it's the consenting strategy and process is something that we're hoping to kind of roadmap and understand a little bit better. So we go, yeah, and I think that we can maybe come back to you on that. So maybe a more specific answer I can reach out to.
Brilliant. So is the Continuum software-based dataset restricted to land-based pipelines, or could it also be used to quickly assess, compare offshore pipelines options during strategic options development, very early feed? So yes, we do currently undertake offshore projects as well. We do have some case studies showcasing this work on our website. So please do get in touch if you'd like more information. How will the software stand up to scrutiny in a public hearing within a DCO process? So the company's been about 4 years old. So a lot of the projects we've worked in, of course, are quite substantial, and they haven't hit that DCO process yet, or we don't have visibility over how that has gone. However, what we're finding is that during people's engagement with stakeholders and the public consultations, that when people are questioned on, why did you consider this option? Why haven't you considered this? Or, could we go around this way? That's actually they can very quickly justify if they have considered that option and why they didn't opt for it. Or if they haven't considered it, then add it to the analysis and run it very quickly, and then compare the metrics to determine the trade-offs and what that would actually how that would affect other aspects of the project as well. So the next comment or question was no mention of input from planning authorities for further built environment development within the future projected life of the hydrogen pipeline system. When in your process do you consult with the authorities? So I think this was one for you, Ali.
Yeah, so as I say, we're carrying out we're developing a stakeholder strategy at the moment with all those authorities included in that. A few of them are sort of categorized into pre-feed and feed stage. So now that we have a sort of corridor that we can sort of back, if you will, there's a few of those authorities we'll look to engage with within the lifetime of the project, and if not, at the feed stage. So we're kind of taking an approach of trying to do the engineering first to sort of create a credible plan or corridor for this, and then carry on with, and then in parallel develop that consenting and stakeholder engagement strategy, which is really important, is actually starting to move quite well now. So yeah, there's sort of more to come on that, and I think at the end of the project we should have quite a coherent plan there for engagement, because it's a little bit of an unknown quantity, because it's not this sort of scale hasn't been attempted for quite some time.
Brilliant, thank you. So next question was, as the AI software is based on data, the GIGO, garbage in, garbage out, applies. Therefore, presumably, stakeholder input and construction and environmental, etc. SME resource is critical in establishing the constraints, weightings, etc. What is your typical time frame? What typical time frame was allowed for this period? So typically, we have a data review where we discuss these, essentially the constraint weightings, about 2 weeks into the project. So that's when we've had enough time to exchange any information about the project and develop a data register relative to the project requirements. And then we get all of the different disciplines into one room, and then we discuss the weightings. Typically, about 3 days after that, we will then have a data freeze, where we will freeze those assumptions, and then we implement that in the tool, and then we iterate on them once we see the results. So if we have made an assumption that was maybe too rash, then we can iterate on that and account for that in later stages. But yes, as you're stating, garbage in, garbage out, we've been essentially specializing in the actual routing and optioneering of linear infrastructure pretty much solely for about 4 years. So the baseline data offering, made up of open source data, of course, is we've got a pretty good baseline that is pre-populated in projects. The next question was, what data accuracy is there, and how do you exchange data with other utilities, etc.? So the platform runs at, as its standard, 30-meter resolution, but we can reach 5. Typically, we find that for the developments of this scale and at this stage, 30 meters is more than suitable, and it provides a lot more granularity than you typically would have at the early stages of the project. And how do we exchange data with other utilities? So some of the utility data is open source. We don't have a sort of understanding of any utility data which isn't open source. So typically what we do is obviously provide diverse options. And then as you go forward and you request that utility data for specific corridors, we upload that into the app, and then we refine for that as well. So that'll be taken in typically at a slightly later stage, once we have an idea of where you actually want to purchase that data for. And then assume majority of analysis based on public data initially. So yes, any public data and then any commercial data sets that the particular customer we're working with has access to can also be included. We can also start to model slightly more nuanced aspects of the project. So by getting in maybe land specialists or environmental specialists who have ideas about areas that they would like to avoid or maybe think could be an opportunity. And we can draft that into the app very quickly and then add that as a data set. So there's kind of a quicker way rather to model constraints as opposed to waiting for other people to send us through data sets all the time. Okay, that's the last of the, oh, sorry, I didn't scroll down. Assume majority of how was sensitive data procured and analyzed, i.e. MOD, utility distribution, generation networks, geotechnical risk areas. So yeah, again, sorry, this was just the last part of the initial statement. So yeah, this is dependent on what the customer has access to, essentially, at that stage.
Yeah, we were able to fill pretty much all the utility data was sort of, if it wasn't in the public domain, we were able to source it from those the data owners through our partnerships. So yeah, I think we covered most of it. I think in the end, everything that would influence it in a major way. Any other questions?
That seems to be everything in the chat. You have our details if you'd like to follow up with any questions later, and we are happy to circulate the slides. And I believe that Pipeline Industry Guild also put a recording of this online. So for me, thank you to Pipeline Industry Guild for hosting. Thank you very much, Ali, for coming along and yes, showcasing our work together. And thank you for everyone who attended. So we just got a new question. So have any governmental bodies used this software? I don't. They will have seen it, and they will have probably seen the results from it, but I'm unsure if they've actually been in the platform and utilized this.
I think that's us questions wise. Yeah, big thanks from me as well to the Pipeline Industry Guild for having us. So if you have any, I'll put my email in the chat as well. So it's not the presentation if you have any follow-up questions. But yeah.
Perfect. Thank you, everyone.
Thanks all.